Okay, we're asked to find the domain, the range of this function here, and a few of its values. So let's start with the domain. So when it comes to these domain problems, you want to look out for three things, usually. Division by zero, square root of a negative number, and when I say look out for these sorts of things, what I mean is the domain is by definition all x that you can actually plug into this formula and get something out. So what could possibly go wrong? Well, you could end up accidentally dividing by 0 when you plug in certain values of x. Or you could end up taking the square root of a negative number. But there are other functions, so the formula uses other functions that aren't defined everywhere. So you have to look out for those too. So especially things with asymptotes, like, so examples are the tangent function that has asymptotes, ln has asymptotes and it's not defined for negative values of x, and so on. So let's just quickly recall what the graph of ln looks like. It has this kind of asymptote to negative infinity as you go. It's not actually defined for x equals 0 or for any negative value of x. So you better not have a negative being plugged into an ln. And tan x has some asymptotes as well, things like negative pi halves and so on. Alright, but for our particular formula, we clearly don't have any kind of division at all, so we don't have to worry about division by 0, and I don't see any weird functions in there like tangent or logarithm or anything like that. So the only thing we really have to worry about is potentially taking the square root of a negative number, because we do have a root there. But it's not a square root. When you actually look at it, we're taking the cube root of something. So what does the cube root function look like? Well, it looks like the x cubed function. So let me just draw the x cubed function. It looks more or less like that. Except how do you find, since the cube root function is the inverse of the cube function, they're opposite each other, how do you find the graph of an inverse function? You draw this line given by y equals x, this just kind of 45-degree line, and you just reflect everything like a mirror across this line. And so when you do that, the graph will look something like this. And there's the graph of f of x equals, maybe I shouldn't call it f, I'll call it g of x, equals x cubed. I'm sorry, cube root of x. X cubed is over here. So that's cube root of x, just like that. Okay, so it's actually defined for all real values of x because you can take the cube root of a negative number. Because, for example, negative 2 times negative 2 times negative 2, these two minus signs cancel, but then you have a third one left, so this equals negative 8. So the cube root of negative 8 is equal to 2. So even negative numbers, is equal to negative 2. It's negative 2 that we had cubed. So even the cube root of negative numbers exist, and they always end up being negative. So actually here, the domain is all real numbers. There's actually nothing that can go wrong. We're not taking a square root. And, as a general rule, it's not just square roots. It's also any even root. So here we had an odd root. We had a third root, so we didn't have to worry about it. But if you had an even root, it would have the same problem as square root, because you can't define the even root of a negative number. The minus signs would cancel. This kind of trick where you need an odd number of minus signs to get another minus sign. So the domain is all real numbers, and we'll write it in interval notation from negative infinity all the way to infinity. Alright, so what about the range? That one's going to be just a touch more complicated. Alright, so how do we do it? Step 1 is that you write down the equation f of x equals r. I'll choose the variable r. R stands for range. So for us in particular, this is the cube root of 1 minus x squared equal to r. Is that right? Yes. Cube root of 1 minus x squared equals r. So step 1 is write down this formula. Step 2, solve for x. in terms of r. So when we do this, well, let me just jump right to the third step, which is kind of an addendum to the second step. Okay, when you're doing this, pay attention to any place you may have divided by 0 or taken the square root of a negative number. And again, square root can be replaced with any even root. Negative number. So what exactly do I mean? Well, let's just jump right in. Let's actually solve this equation for r. So we cube both sides, we get 1 minus x squared equals r cubed. We didn't do anything wrong there. You can cube any number, so we haven't made any potential algebra mistakes. We can add x squared to both sides. 1 equals r cubed plus x squared. Then we can subtract r cubed. Remember, we're trying to solve for x. 1 minus r cubed is equal to x squared. And finally, and this is the critical step here, you'd want to take the square root. Square root of 1 minus r cubed equals x. But I've made two mistakes right now. First of all, when I'm solving x squared equals something, it's not just the positive square root I'm interested in. I should also maybe take the positive and the negative square root. So that's kind of a small mistake, a slight mix-up, but it's not the real issue here. We're not so interested in actually solving the equation. We just want to know that the equation can be solved, because what does it mean for you to be in the range of something? It means that there's some value of x for which f of x is equal to you. There's some value x you can plug in to get this value r out. So at this point, what we notice is, hey, wait a minute, at this stage we have to take the square root of a number, and it would be really, really bad if this number inside the square root was negative, because then we couldn't solve for it. So just to give you a specific example, switch colors over here. To give you a specific example of what could have gone wrong, suppose that we had r equal to 2. What would have happened there? You would have had 1 minus x squared equals 2 cubed, which is 8, just plugging that r equals 2 into that first one. And then you would have subtracted 8 from both sides, and you would have gotten negative 7 equals x squared, so I just jumped right into this part of the formula. And then when you take the square root, we have a problem, because there is no number, no positive real number x or negative real number x that you can take, that you can multiply by itself to get to negative 7. You can't take the square root of a negative number at this point, so something goes horribly wrong. So as a general rule, we have to ask ourselves, when will this actually be defined? When can we take the square root of 1 minus r cubed? So that's why I'm telling you, pay attention to any place you may have divided by 0 or taken the square root of a negative number, because that means that something potentially illegal just happened. Alright, so when did we? What do we need? What restriction do we need to place on r to ensure that this makes sense, that we are allowed to take the square root of this number? Well, we better have 1 minus r cubed bigger than or equal to 0. And it can be 0. I mean, the square root of 0 is just 0. But then we move r cubed to both sides. 1 is greater than or equal to r cubed. And then, well, when is r cubed bigger than or equal to 1? I think I already have a graph of what the cube function looks like. When is it bigger than or equal to 1? Well, when r is bigger than or equal to 1. As long as r, if this is the r-axis, as long as r is bigger than 1, r cubed will also be bigger than 1. So 1 bigger than or equal to r. So as long as r is less than or equal to 1, when you cube it and subtract it from the number 1, you're going to get something greater than or equal to 0. And when r cubed actually equals 1, that's how you'll get the 0. So this is our range. It's the allowable values of r that would allow us to solve the equation f of x equals r for some value of x. As long as r is less than or equal to 1, we can solve the equation. In interval notation, we'd write it like this. I put a closed bracket here because we want to include 1. That's not a strict inequality. And then finally, they just ask us for some basic values. Calculate f of 0, calculate f of 3. This is very easy. The cube root of 1 minus 0 squared is just 1. And the cube root of 1 minus 3 squared is, well, 3 squared is 9, and 1 minus 9 is negative 8. And we already calculated that. That's negative 2. And then finally, we're asked, well, does f of x ever equal 0? And the answer is yes. So the equation would be f of x is cube root of 1 minus x squared equal to 0. You cube both sides. 1 minus x squared should equal 0. And then you move the x squared over. 1 should equal x squared. And again, you take the square root of 1, and you get x equals 1. But you should take plus and minus the square root, which is plus and minus 1 itself. So there are actually two values here. X can equal plus or minus 1.